functions, okay, where they are defined, okay, by the following arrow diagrams, arrow diagrams, okay, okay. So where they're defined by the following arrow diagrams. Okay, so what we're going to do is we're going to take the set A, the set B, and the set C. Okay. Actually, this time what I want to define, let's just define it again. What I'd like to define is I'd like to construct the function g after f, okay, where this is the set A, so it contains the values 3, 7, and 4. This is the set B that contains the values 2, 5, 6, and 9. And this is the set C that contains the values 7, 6, 5, and 4. Okay, and let's say A is defined to be, well, we have 3 is taken to 5. Okay, we have 7 is taken to 9. Okay, and we have 4 is taken to 2. Okay, so this is the function f. Okay, this is how f works. F takes, well, you can see it is a function. It takes every single value in A. Okay, it takes every value in A and maps them into values in B. Okay, that's the first condition. The second condition is that we don't have a situation where we have double arrows leaving values in A going to separate values in B. So that's not a situation here. So hence f is a function. Let's define G to be the mappings. Okay, let's say that G is the mappings. Okay, let's say we have something like 2 is taken to 7. Let's say we have 5 is taken to 5. Let's say we have 6 is taken to 6, and we have 9 is taken to 4. Okay, so this is G. G is a function because you can see that every value in its domain is mapped into some value in this codomain. Okay, and also we don't have any double arrows leaving any of the values in the domain going to separate values in the codomain. Okay. So, how can we define this function? How can we write this function down? Okay. Well, I suppose we could actually do the mapping. So let's do the mappings. Yeah. So let's do. Where's 3 taken to? 3 is taken to 5. So we have for this function here we have 3 is taken to 5. Okay. For the function f. Okay. What we also have is 7 is taken to 9. So 7 is taken to 9. Okay. And what we also have is we have 4 is taken to 2. So we have 4 is taken to 2. Okay. Okay, now what happens to these particular values, okay, based off the function, okay? Well, the function g then takes the value 2, okay? It takes the value 2 to 7, okay? So here's the value 2, so 2 is taken to 7, okay? The value 5 is taken to 5, so 5 is taken to 5, okay? The value 6 is taken to 6, but we don't have any 6's being mapped here, okay? That's okay. But the value 9 is taken to the value 4, so the value 9 is taken to the value 4, okay? So this is G, okay? So the function G after f, okay? So the function G after f, okay, which is G was done after we did f. The function G after f is the mapping 3 is taken to 5, so it's 3 is taken to 5. It's 7 is taken right through to 4, so 7 is taken to 4, and 4 is taken to 7, so we have 4 is taken to 7. Okay. The important thing here to note, yeah, is this function G after f. Okay, it takes the values 3, 7, and 4. So G after f, okay, is a mapping from 3, 7, and 4. Well, 3, 7, and 4 is this set A. Okay, so it's a mapping from A into, well, you can see it's taken into 5, 4, and 7. 5, 4, and 7 is a subset of C. So this is its actual range. This is its range. Okay, this is the range of the function. Okay, this is the domain of the function. So here's the domain. Okay, here's the range. Okay, they're the actual values that are mapped into. And this particular range is a subset of C. It's a subset of this codomain, so it's a subset of C. Okay, so that's what we mean by G after f. The important thing here is this, is that when you're doing composition of functions, that G after f, that's what it means in words. G is performed after we perform f, okay? And the important thing is this, is that we do f first, Okay, we do the transformation, or we do the mapping from the domain of F into its codomain, and then from there we do the mapping from the domain of G into its codomain C, which gives us a new function, if that makes sense. Okay. Is G after F a function? Well, let's have a look at it here. You can see that every value in the domain is taken to values in the codomain. Okay? And also, we don't have any double arrows leaving values in the domain, so hence G after F is a function. Okay, guys. In the next example, what we're going to have a look at is we're going to have a look at some general functions, where instead of providing situations like this, where we actually are providing the specific values that are mapped across, we'll define them using I suppose, let's say using polynomials and so on, and function and other types of more functions where we have x's and y's, if that makes sense. So guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this video, a short video on what we mean by composition of functions, I hope that this was in some way helpful. Well, I hope it was intuitive, and more importantly, I hope that was helpful for you. And thank you for watching. Okay, bye-bye.